Hello and welcome to part 2 of my series on mycotoxins. This is a multi-part series. In part 1, I just defined mycotoxins and talked briefly about a few different classes. Part 2 now, I want to get into the history of mycotoxins and kind of the history of mycotoxin research and why we care about them and why we historically cared about them. I tried to be brief. This is mostly focusing on one, maybe two classes of mycotoxins. So this is absolutely not comprehensive, but it gives some good examples of how we come to learn about them. First off, a little trivia. What is this animal? If you're guessing a chicken, you are close because this bird is a turkey. And what is a young turkey called when it's grown for commercial reasons? Anybody? It's called a poult. You think of the word poultry. That's something I learned here. I did not know that a young turkey was called a poult. So why am I talking about turkey poults? Well, back in 1959 and 1960, there was, I think, 100,000 young turkeys died kind of all of a sudden, and in some cases 50 to 100% mortality. They could not get turkeys to live past a few weeks or a few months old, and they had no idea why. They had no idea why this started so quickly. So there was a fella, Dr. William Percy Blunt, who investigated this. He was a veterinarian and actually a very well-renowned veterinarian. And a lot of the early research you'll see in all of mycotoxins was done by veterinarians. And why? That's because these effects were often seen in livestock, not in humans. So it was veterinarians, not like toxicologists or public health experts that did this early work. This paper is fantastic. If you have time and you want to read an older paper, it's from 1961. And this guy went total Sherlock Holmes. This was in Britain. And he was investigating why all of these young turkey poults were dying. His investigation, he went through everything, and it ended him up on a flight to Brazil. And he went to Brazil because in 1959, Britain started using this peanut meal. So this meal is the peanuts. It's the oil that's removed and it's what's left over. So it's high in protein, and it's a very common supplement for animal feeds to give the animals some protein. And it's low in fat because they remove the oil. So he went to Britain, and using his Sherlock Holmes techniques, he looked at the peanuts. He looked at that being maybe the source, like these bad peanuts being the source of that toxicity. He also looked at other things such as caffeine carried over from nearby coffee plantations. And at the end of the paper, by the time it was published, he unfortunately still didn't know what the root cause was. They still called it turkey X disease at that point because they didn't know what the disease was, so it was X disease. But very, very soon after that, by investigating the peanut meal, Dr. Blunt and some others determined that the peanuts were contaminated with this mold called Aspergillus flavus. And this mold, it seems to be, once they isolated the mold and grew the mold on its own, extracts of that mold were deadly to turkeys. They would kill all the turkeys. So they found that it was this mold that was causing the problems. Aspergillus flavus. And so they didn't know what to call the toxins that came from it, but looking at the word Aspergillus flavus, they came up with the word aflatoxin. So they, from flavus, they got the FLA and the A from Aspergillus. So that's where, and aflatoxin is one that a lot of people have probably heard of. This is one in peanut butter recalls. This is one that's highly regulated in the US and around the world. When aflatoxins were initially discovered here, they found that mold and the compounds that they isolated from the mold that seemed to be causing that toxicity were very fluorescent. And what fluorescent means is that if you shine a UV light, so kind of like a black light, if you shine a UV light on it, it glows a different color. And the color is something you can detect because it will be a color on the visible spectrum. So the first aflatoxin that they found, aflatoxin B, was named aflatoxin B, not because it was alphabetical A through Z, but because when they applied UV light to it, it fluoresced blue. So it was nice and shining blue. They discovered a new aflatoxin, aflatoxin G. And if you have a guess there, you're probably right. Aflatoxin G fluoresces in the wavelength and the spectral range of green. So the G is for green. And then soon after, as a little later, they discovered a different class of aflatoxins called aflatoxin M. So if you had to have a guess, you might guess magenta, but you would be wrong. It's not magenta. M stands for purple? That's weird. Indigo? No. Actually, M, even though it fluoresces in that violet part of the wavelength, it's named M because it comes from milk. If you tuned into the first episode, you saw me complaining about how the definitions of mycotoxins were strange and not well organized. Well, even the naming of these mycotoxins is a little strange. So we started naming them based on wavelengths and then named this one aflatoxin M because it's in milk. This is actually a metabolite. It's not M because it's a metabolite. It's M because it's in milk. So that is odd. And then from there are other aflatoxins, MNOPQ. They're like all metabolites. But I don't think the other ones, I tried so hard to look up what aflatoxin Q stood for, and I couldn't find anything. I think it's just alphabetical after M. So aflatoxins, even though I talked about them being discovered in the 1960s, but that doesn't mean they were actually just started being formed in the 60s. They've been formed way back into time. Pretty much as long as we've had grains that can be moldy, we've had aflatoxins and we've lived with aflatoxins. There are many, many other mycotoxins out there, including the ergot alkaloids, and the historical record of these goes way back. So this is an Assyrian tablet. The one I'm showing here is not the one, that is just an example. It's not the one that had this quote in it, but there apparently is one that talks about a noxious pustule in the ear of grain. And then there's multiple historical references about this class of alkaloids that appears to also be a mycotoxin. It's a very interesting class because if you look at the structure of one called ergotamine there, it's very similar to lysergic acid. And if you recognize that word, but you don't remember where, you'll see why in a minute. Let's fast forward to year 500 to 1700s. Multiple manuscripts define this slow nervous fever being what they thought was exposure to something in contaminated grains, which we later learned to be ergot alkaloids like ergotamine. Even through to the Salem witch trial, there's theories that the people who were deemed witches and burned at the stake actually were not witches. They may have been contaminated by these ergotamines and these that cause neurotoxicity, and they cause maybe you to go a little crazy. That may have been happening around the world at that time, but it was just in Salem that they actually decided that they were possessed and they were witches. So that's kind of interesting. There's actually been a book or two written about it, a fiction kind of book. I should read it, you should read it, but I haven't yet. Another very interesting little tidbit about the ergot alkaloids, it was Albert Hofmann who was using lysergic acid and using ergotamine, using some of these compounds as starting materials, and he was a synthetic chemist, and he was making all kinds of different structures from that lysergic acid. And if you look at the structure here of ergotamine, you'll see it's very similar to the 25th compound he made, which was lysergic acid diethylamide, aka LSD. That's a little LSD tablet there that has his picture on it, because when he invented this, if you don't know the story, he accidentally got some in his mouth, was exposed to it, and had a very interesting bicycle ride home. So that's the history. That is a brief history of mycotoxins. I just went through 2 classes, but hopefully you got the point, is that mycotoxins have been around longer probably than we've been around, but we've only known about them since probably about the 1960s. And since then, we have defined and attributed a lot of different compounds as being mycotoxins. So we do know about them, but we still don't know everything, and research is still ongoing to figure out, new ones that are out there and how we're exposed, what's the toxicity, what's the risk. And that's what I'll be getting into in some of my other series. So thank you for joining today for the history of mycotoxins, and I hope you enjoyed.